So we have periodic table. Okay, so we have periodic table, and in periodic table you saw lots of elements. Okay, and in that element we have some element is the stable element. Okay, a stable atom, or some element is the unstable element, and that element which have the atomic number that is greater than 82, so that is the unstable element, unstable nucleus. Okay, that's have a nucleus which is unstable, and you can say that that element is the radioactive element. Okay, so that is the radioactive element. Okay, and that will be unstable. Unstable means that after some time it will disintegrate. Okay, it will divide. Like if this is if this element contains 1200 atoms. Okay, so it will disintegrate after some time. Okay, and it will be like convert into another element. Okay, and that is, let's say, 600 atoms. Okay, then after, yes, then after some time it will again disintegrate and convert into a new element, which is C element, and it will contain atoms that is 300. Okay, so with the passage of time, the radioactive element get disintegrate. Okay, and it become a new element. Okay, and this process will go on until either the atomic number is less than 82, or it become the Z. Z is the atomic number, which this is the alphabet which we represent. In your chemistry class you studied this. Like we represent it by like this. Element is represented by X, A, Z. Yes, Z is the mass number, and A, no, Z is the atomic number. Yes, yes, atomic mass. You remember this periodic table? Some student, you remember all the elements, like first hydrogen, helium, lithium, barium, boron, carbon, nitrogen, oxygen. I also remember this. Actually, I remember this periodic table for my entry test. In entry test, sometimes MCQs come like this, that nitrogen has atomic number dash, so you should remember this time this periodic table. Actually, periodic table is not allowed here in exam, so that's why. And mostly in entry test. Yeah, so actually, the invigilators don't know what is mean by time periodic table, so that's why they not allow allow the periodic table. So that's why all students here who want to give entry test for university, so they remember the elements. They also make some sort of formulas. Like my sister remember the formula, and she also tell me that na that was in Urdu. That is na paas raho sab bewakoof. I think that is like this. Na na oh yes, na paas ao sab bewakoof. I think that was the one was this one. Na paas ao sab bewakoof. This is in Urdu. No, no, na means nitrogen. Pass means phosphorus. Oh, I don't know. Oh, nitrogen, phosphorus. Then lithium, I think. Sub means antenum. Bewakoof means boron. That is like this. She remember. She told me about this a few months ago. Actually, when I give entry test, then sometime MCQs came from the semiconductor. Okay, in semiconductor we study their MCQs come like the third group element. Okay, so you should remember the elements of the third group. As an electrical engineer, we also remember this periodic table, because in semiconductor, you know P type, N type. I think you not study about the semiconductor. Okay, okay. Later on we will study about this. So in there we use this. We should remember this periodic table for integers. As an electrical engineer, you should remember this periodic table. Okay, so this is the atomic mass. Okay, Z is the atomic mass. Okay, so this will be your atomic number, and this will be your atomic mass. Okay, like hydrogen, you will represent it by a 1 1. Helium has atomic number 2, and what is the mass? Mass is, I think, 4. Yes. Okay, so you will remember represent the element like this. Okay. Okay, so now in unstable, now we need, okay, this is you get that what is mean by unstable nuclei. Okay, now we need to go inside that. What which type of forces is present inside this nucleus? Okay, due to which it becomes stable and unstable nucleus. This is nucleus. Okay, and we know that inside nucleus we have lots of protons. Okay, and we so we have lots of proton. Okay, and lots of neutron. Neutron have no charge, but proton have charge, and that is positive. Okay, so in Coulomb law, Coulomb law, we study that if two positive charge are near to each other, then in between these two positive charge there is this a force, and that force is the electrostatic force. Yeah, electrostatic force, and this for if these two charges is same, then these two charges will repel each other. Okay, that is the electrostatic repulsion. Okay, but this nucleus is stable nucleus. So how this is stable nucleus? So it means that there exists some sort of force which is opposite to electrostatic force, and that is the strong nuclear force, you can say. Okay, so this strong nuclear force will overcome the repulsion. Okay, repulsion due to the electrostatic force. Okay, and it keep the proton and neutron together. Okay, due to nuclear force, it keep the all protons and all neutron together. Okay, it is just like a gum. Okay, so yeah. Okay, the range of this nuclear force is no more than 3 to 4 femtometer. Okay, it means range is less or greater. The range of this force is no more than 3 to 4 femtometer. Femtometer means 10 to the power minus 15 meter. Okay. And the diameter of the nucleus, what is the diameter of the nucleus? That is 1.7566 femtometer. Okay. For hydrogen. Hydrogen have only one proton. Okay. So it means the diameter of the nucleus which contain one proton is 1.7566. Okay, you can say that this is the diameter of the single proton, while the electrostatic force has no limit. Okay, limit for nuclear force, and electrostatic force have no limit. Okay, we will also you will also see that in the graph. Okay, later on I will also draw a graph, and then you will see. But the electrostatic force get decrease as you increase the distance between them. Okay, if you increase the distance between two charges, then the electrostatic force will get decreased, because F is directly proportional to Q1 Q2 divided by R square. Okay, so it has an inverse relation. Electrostatic force will get decreased if you increase the distance between them. Okay, there is a limitation. Okay, in nuclear force there is a limitation. If there is no limit in nuclear force, then this proton will go inside to the another proton. Okay, like this proton will absorb this proton. So there is a limitation that if you decrease the distance. Okay, nuclear force, due to nuclear force, the distance between these proton will get decreased. Okay, so it will be near to each other, but there is still limitation that if you cross that limitation, then these two will repel each other. Okay, and due to that limitation, this proton will not absorb this proton. Like if you bring it more closer, okay, then it will be like this. Okay, so this proton will absorb this proton. So there is some sort of limitation due to which it will be present like this. Okay, it will not go inside to each other, but it will be near to each other. Okay, so this, due to this nuclear force, this proton will be close to each other, but no. Next point is the nuclear force will have a same effect between two protons. Okay, if you bring two protons, then it will have the same effect. Or if you bring two neutrons, okay, then it will also have the same effect. Or proton and neutron. Like it is not like the this that if you increase the positive charges and decrease this the positivity of this charge, then the effect will get increase or decrease. Okay, like if you bring negative charge, then the effect will be opposite, but here the effect will remain same. No, this is the characteristic of the nuclear force. The nuclear force will remain same, will have same effect between two particles. Like it nuclear force not depend on the charge, while the electrostatic force depend on the charge. Like in electrostatic force, you will also bring the positive and negative charge. Like you will also give that this charge is positive, and if this charge is also positive, then these two charges will repel each other. But if this charge is negative and this charge is positive, then it will attract each other. Okay, so it depends on the charges. But here the effect will remain same. If you bring two positive charge, then it will attract each other. If you bring this to this, then it will also attract to each other. Okay, through nuclear force. If you bring these two, then it will also attract each other to nuclear force. But nuclear force is too much small. Okay. Okay. Third point it is okay. Range range of nuclear force. Radioactive force has no limit, but it get decrease as you increase the distance between them. Got it? Next point is nuclear force has same effect between two protons as it has between two neutrons or a proton and neutron, unlike electrostatic force. You send something to me on Skype. Okay, I received message on Skype. Okay. Third point is that it has attractive force. Okay, I discussed about this. It has attractive force from 3 to 4 femtometer. 10 to the power minus 15. I told you about this. Down to nuclear force. Has attractive force from 3 to 4 femtometer down to about 0.5 femtometer. But if this separation, this is the separation, but if this separation is smaller, then it will become a repulsive force. Become a repulsive force. Why? Because that act to prevent neutron and protons being pushed into each other. Got it? Okay, in last slide, range, this is the range. Okay, range is no more than 3 to 4 femtometer. Okay, if you increase the distance greater than 3 to 4 femtometer, then the nuclear force will get zero. Okay, so the range is 3 to 4 femtometer. But okay, let's say this is if this is neutron proton and this is proton, and distance between this is 4 femtometer. So it means if you increase this proton, okay, if you increase the distance between these two, then the nuclear force will get zero. Okay, and if you decrease it, then the nuclear force will exist. Okay, and it will be attractive. It will be attractive. It will be attractive. But if you decrease it to 0.5 femtometer, up to 5.5 femtometer, it will be attractive. But if you decrease it further, then it will become repulsive. So it will go back repulsive. Then it will come attractive. Then repulsive, attractive, repulsive. Okay. So due to which it prevent neutron and protons, like two protons or neutron and protons here between protons being pushed into each other. Okay, it prevent this to push into each other. No, that is the electrostatic force. Due to electrostatic force, this positive charge will repel this positive charge. But due to nuclear force, uh, it will not repel each other. Yes, yes. Then the nuclear force will act as a repulsive force, not as an attract. Yeah, it will repel. Okay. Otherwise, one proton will go inside to the next proton. Okay. Then the identity of one proton will be destroyed. So that's why it will repel each other. Okay. So in this case, in this way, the nucleus is stable and it will contain a discrete amount of protons which is present inside nucleus. Got it? Okay. The graph is like this. That uh, yeah. Actually, in hydrogen we have one proton. In helium we have two proton. Okay. Okay. If this property not exist, okay, if this third property not exist, okay, then what will happen? This proton will go inside this proton. Okay, then you will get one proton. But due to that property, you got these two protons. Okay. Okay. Let's say we have this is proton or neutron. You can say, okay, either this is proton or neutron. Okay, and this is the center of the proton. Okay, so this will be force. Okay, this is 0. Here you will get a repulsive force, and here you will get an attractive force. Okay, and this is the distance from the center. Okay, now we need to draw the electrostatic force and nuclear force graph. So the electrostatic force graph will be like this, inverse relation. What about the nuclear force? So you mean that if you increase the distance, then it will increase, the repulsive force will get increased. Yeah, the if you but that is the that has a limitation. In this electrostatic force, there is no limitation. Okay, it will go like this. Okay, but in electrostatic force there is a limitation, and that is like this. Here your electrostatic force will get 0. It means this distance is 4 to 5 femtometer. Sorry, 3 to 4 femtometer, but so 4 femtometer. Okay, so this is attractive force. But if you increase the distance further, like this is, let's say, 0.5 femtometer, then it will become repulsive force. Okay, got it? So the graph will be like this. So here you will get a 0 like this. So this is the graph of the two forces which is present inside the nucleus. Okay. Okay, now we need to do an experiment. Okay. Okay, so we have a chamber. Okay, and chamber is yes. Okay, so we have a lead chamber. Okay. Actually, how alpha and beta gamma radiation is generated. So through this experiment, we will generate the we will do a radioactive decay. You can say radioactive decay experiment. Okay, so this is the lead chamber. Okay, and inside the chamber we have a box. Okay, and in that box we place a radioactive element. This is the radioactive element. Okay. So this radio. Okay, outside this box we also place another box, and we also place the photographic plate. Here we place the potential difference. Okay, electrodes. This is the negative electrodes, cathodes, and this is the anode positive. Okay, so this due to this radioactive element, radiation is emitted. Okay, and radiation is emitted all the time on all sides. But here we have a lead chamber, so this region is open. So radiation is going like this. One radiation go like this, attracted toward the negative electrode. Another radiation is attracted toward the positive electrode, and third radiation is going straight. No attraction and repulsion occur in this radiation. Okay, so this radiation we call that this is the gamma radiation, which is neutral. This radiation is the alpha radiation, okay, alpha nature, and this radiation has a beta nature, which has negative charge, and this has positive charge. Okay, so and we study about this radioactive element. Okay, this element has atomic number that is greater than 82. Okay, so it will emit radiation and it will convert into another a new element. Okay, and this element, like this element is, let's say, A, which has atomic number that is greater than 82, and this element is known as the parent element. When it converts into a new element, then that is known as the daughter element. Okay, so this process is known as the nuclear transmutation. Okay, so tomorrow we will do this then. Okay, there is alpha beta gamma radiation. We need to explain that. Okay, then after that we will study about the photons, electromagnetic waves, and we also study the antimatter. Okay, which is the opposite of matter, which is the positrons. Okay, which is the opposite of the electron, and we will also study annihilation and the pair production.